Welcome to section 4.4. In 4.4, we're going to be looking at how to count. So I'm going to just call it counting. And the best way that I can describe this, I would recommend that you read the book and see what they're saying. But the best way that I can teach you how to count is with the series of questions. So the first question that you're going to ask yourself is, are repeats allowed? Now, there's two answers to that question. If the answer is yes, then you do what is called repeated multiplication. So let's look at a few examples where the answer is yes. So let's suppose that somebody, call this example 1, somebody stole my ATM card. What is the probability that randomly, that a stranger randomly guesses my PIN number with one try? Okay, now in order to answer that question, I'm going to need to know how many different PIN numbers are possible. The probability that they get my PIN number correct is definitely one option out of a bunch, but I need to know what this bottom bunch number is. That's what we're counting. So sometimes they're asking for what is the probability, other times they're asking for how many ways can that happen. And so you'll just answer the question that's being asked. So the probability that a stranger randomly guesses my PIN number. So let's think about a PIN number. A PIN number is 4 digits long. And can there be repeats? Is this an acceptable PIN number? 6762. Could I repeat that 6? And the answer is yes. So this is what we mean by repeats are allowed. Once you use something, could you use it again in a sequence? Absolutely. In this case, it's not always the case. So whenever that happens, you do what I've termed repeated multiplication. So you worry about it slot by slot by slot. So how many choices do you have for the first number? Well, you have 10 choices. Here they all are. Got to sneak that 9 in there. There's 10 choices for the first number, and the same 10 choices for the second, and the same 10 for the third, and the same 10 for the fourth. Almost always it's the same number repeated, unless there's something special that they're describing, and they do that in the book and in the homework. So 10 times 10 times 10 times 10, that's 10,000. So you have a 1 in 10,000 probability of that the stranger has a 1 in 10,000 probability of just randomly guessing my PIN number on the first try. So it's pretty safe, provided they don't know anything about me or what I might have chosen for that. That's an example of repeats being allowed. Another example. A couple plans to have 4 children. How many different gender sequences are possible? So this is a how many. Okay, so let's make sure you understand what they mean by gender sequence. This is a gender sequence. Girl, boy, girl, boy. That's a sequence that's different than this sequence. Boy, girl, girl, boy. It would be different if there was the older brother as opposed to the oldest sister going in there. And so those are two different gender sequences. You might remember having listed those out earlier in chapter 4. But my question to you is, could gender be repeated? Yes, it would almost have to be. Well, not almost, it has to be. Once you have that second child, you're out of genders. And so it could be girls every time. And so repeats are allowed. And so since repeats are allowed, I put in slots. There's 2 ways to get the first child. What are those 2 ways? A boy, girl. 2 ways to get the second, boy, girl. 2 and 2. And so you get 2 times 2 times 2 times 2 for 16 different ways. And if you remember, you listed out those 16 different ways. Now, sometimes the answer to this question of are repeats allowed is no, and that's a good thing, because when it's no, it means we can turn to a button on our calculator and it's just going to spit out these large values. And so I just want to teach you those formulas right away, because we need one of those as we move forward into chapter 5, especially in 5.2, specifically in 5.2 is where that will be. So just taking a moment just to erase this so we don't get too far below this graph. So the answer absolutely could be no. And if it's no, that's when we ask the second question. Does order matter? Alright, so let's talk for just a moment. Let's suppose that I am an employer and I have 50 employees. And I want to create a subcommittee. I shouldn't call it a subcommittee, a work group, right? A work group to help solve a problem. I need 5 people to be in this work group. They would just work together in order to solve the problem. How many different groups of 5 are possible? Okay, so let's talk about that. 50 employees. I'm going to select 5 of them. Are there going to be repeats? Could the same person be counted twice on the committee? No, doesn't make any sense. So I'm asking this, does order matter? So let's pretend that we picked some people. Let's pretend that we picked individuals like Alice, Barry, Charles, Dave, and Eric. Okay. Alice, Barry, Charles, Dave, and Eric. Those are 5 individuals. If these people are on my work group, would it matter which order I picked them? Would it make a difference if Eric was picked first, and Alice was picked second, and Barry was picked third, and let's see, Charles and Dave? Would that make a difference on who's on my work group? Absolutely not. So in this case, order does not matter. So you almost want to, as you answer this question, you really want to picture it as having the individuals already selected or the things already selected, and say, would it matter if I grabbed them in a different order? And if the answer is no, then that's a good thing. If the answer is no, you're going to use a button on your calculator that we'll use a lot in 5.2 called the combinations button. So let me write that out bigger down here, C and R. N is going to be the number of original selections, or original people in the group, in this case, original things you're choosing from. And so in this case, we have a group of 50 that we're choosing, so N's 50. R is going to be the number of people you are choosing. And this formula knows that order doesn't matter. So in this case, R is 5. And so you got this C55. And so let me show you how to plug that in on the calculator. Let's see if I can put this into the video. So I'm going to try to go to my camera. and see how that works. So here's my camera, and I'm going to try to find my calculator somewhere. There it is. Sorry about that. And on my calculator, here's what I'm going to type in. I'm going to type in 50. So let me come in here and type in 50. And then I'm going to go get that C button. Now on my calculator, it's here under the PRB. And I'm going to toggle over to the C and select it by hitting enter. And then I'm going to type in the 5. Oops, I typed in 8, so I got to go back and type in 5. And when I hit equals, there's my answer. 2,118,760. So 2,118,760. That's it. I just write that down. That's how many groups are possible with a group that big, selecting 5 at a time, even when order doesn't matter. The number would actually be a lot bigger if order did matter. Okay, so let's look at another situation. In our class, there are 25 students. If I wanted to form a class presidency, how many different groups could be formed if the presidency was a president, vice president, and secretary? So just 3 people. So let's pick some people. Let's pick Amy, Brenda, and Chuck. Okay, those are the 3 people. So would it matter what order I picked them? Well, let's suppose Amy is the president, Brenda's the vice president, and Chuck's the secretary. Would it make a difference if I left the positions but made Chuck the president, Amy the vice president, and Brenda the secretary? Yes, that would be a different presidency if I just changed the order in which they were selected. So you need to picture this as the first person that you select being the president, second person being the vice president, and third person being secretary. So the difference between these 2 problems is, in this first one, the people on the work group didn't have any positions. Here they have positions. So when there are specific positions, order matters. And when order matters, when the answer to this question is yes, then we use the P and R button. And so we will be using P, order matters. So one way to remember whether it's C or P, well, you're going to be able to bring notes, so you should be able to remember it. But you're going to be using P and R. So in our case, N is, well, there's 25 students, and I'm selecting 3 of them. And so coming to my calculator, let me clear out what I had, and we'll go back to that calculator. Okay. And so what am I going to do? I'm going to type in 25. I'm going to come up here to my PRB button, and I'm going to select, it's already pre-underlined, the P and R, and then I'm going to type in the 3 and hit equals. 13,800. So 13,800 is the number of presidencies that could be formed. Okay, and so those are the style of problems that they're going to have us do. That is pretty exhaustive over the whole section, so you want to look at it and ask those 2 questions. Are repeats allowed? If so, you're going to do repeated multiplication. Does order matter? Nope, we're going to use C and R. Yep, we're going to use P and R. And so we're going to just evaluate problems just like that. And so they'll have varying examples as you go through. A very common one is something like this. A truck driver needs to visit 7 cities. How many different routes are possible? Now, if he has to visit 7 cities, how many different routes are possible? You're not going to go to the same city twice, so repeats aren't allowed, so it's either P or C. Every time it's a route, order matters. If order didn't matter, then you're going to get the number 1. Because there's just one route. Just hit every city and you've done it. But if you think about it from maybe a time or a gas consumption route, then there's definitely a more efficient route, and so the order does matter. So remember here, he needs to go to 7 cities, and he's going to all 7. So that's a fine thing to put in. So if I do 7, go get my P and type in 7, I get the number 5040. So there's 5,040 routes that are possible. Those are the things that you're going to be doing in this section. Hit me up with questions that you have from the homework over as you apply these principles, and then we'll get them addressed as needed. Keep in mind you do have the MyMathLab support as well, with the Help Me Solve This and with the other lecture videos that are there. So, but reach out, come to Zooms. Not too many are coming to Zooms, so if you need some directed help, those are great times. But also, I've been doing some personal Zoom times as well, so keep that in mind. Thanks.